Cool. So let's go ahead and get started with the first question. The first question is going to be right here. Let's see. So what is an autotroph? Cool. Also, if I'm going fast and you don't get it down, it's all going to be available on the video. So I'm just going to keep on moving on. Okay. This is a lot. Yes.
An organism capable of self-nourishment.
Yeah. So, right here, one. That was a good answer. An organism that takes in inorganic energy, light or chemical, and turns it into organic energy. Cool. And examples of that, right?
It's not showing it on camera.
What do you think? I can't see your name. What do you think?
It looks good.
That's funny.
I have
All right. Those are going to include plants, grass,
algae, and some types of bacteria.
trees. Yep, that's right. Okay. Now the other type, right, are going to include chemotrophs. So chemotrophs live deep under the water where there's no sun, and they live by underwater volcanic sea vents. So these underwater organisms take in heat from underwater sea vents. And remember, they turn this into organic energy. Cool. All right, 2. What is a heterotroph? Let's go ahead and, yes?
Heterotrophs obtain energy from foods they eat, such as humans, animals, and reptiles.
Good job. So an organism
Man.
that cannot produce its own energy. It must consume another organism to satisfy energy demand. This might include humans, cows, fish, etc. Okay, cool. 3. Explain the difference between a chemical reaction and a state change. So I want to go ahead and write down these two formulas, right? We have CO2 plus H2O, H2CO3, and this is a chemical change. Right here we have H2O as a liquid. Heat is being applied. H2O is turning into a gas, right? We call this a state change. Now, what is going on right here that differentiates these two? Right here with the chemical change, what we have is we have a rearrangement of the bonds between reactants and products. Right, so we got our reactants right here, we have our products. Okay, so the big thing to recognize, right, is when you have CO2 plus H2O, those are combining to form something completely different, which is H2CO3, carbonic acid, right? Now, if we're going to compare H2CO3 to carbon dioxide and H2O, they're two different things. These have combined and have different arrangements of bonds to form this right here, okay? Now, when you have a state change, think about what we're talking about, right? We're talking about H2O as a liquid, like let's say it's in a pot of water, and we're boiling it and we're turning it into steam. Now, if you think about H2O as a liquid and H2O as a gas, the same thing molecularly. The only thing that's changing is the amount of energy that's inside all of these, in addition to the distance between these, right? So if you have it as a gas, the distance between the molecules is huge. As a liquid, it's smaller. That's right. And deep down, right, when we look at H2O, it still looks like H2O. It's just how much energy is in it, how much distance is between those molecules. So that is the difference between a state change and a chemical change. Okay, so a state change is usually between a gas, a liquid, and a solid, right? But when you look at it, the reactants and products have same molecular arrangement. Cool. All right. So we're going to go to the next one, which is 4. This one is big, right? So how is energy stored? What is the name of this compound? What determines a high energy compound compared to a low energy compound? So this goes over a lot. This is a very important topic. So energy is stored in bonds. When bonds break, energy is released. Cool. And some of the names of those substances, right, that we're familiar with include ATP and glucose. Cool. Now, one thing to notice about ATP is the T stands for tri, right? And when we have ADP, and this is just a little side note, the D stands for di, right? So when we think about high energy and low energy compounds, the first thing you need to look at is the repulsion between those two things that are being held together. So when we think about that, right? Right here, we have something like this. Cool. Imagine we have two people, right? We have large people and then we have smaller people, right? And they're both holding hands. Now, when we have large people, they're leaning back, right? In both groups, they're leaning back. And you have a lot of weight pulling in either direction. There's a lot of force going either way. So when you break this bond, it's going to have a lot of energy. Right here, when you have smaller people, they have less weight pulling them back when they're leaning in the back direction. And because of that, this bond right here has less energy. Cool. And what does that all do to? There's a driving force that basically decides how much energy you get out of two things that are brought together. The driving force between these is the amount of repulsion you have between the two things that are bonded together. So with the people that are larger, right, you have a lot of repulsion because both of them are going in opposite directions and they're larger people. Right here with the smaller people, you have less repulsion. So the trend is, if you have greater repulsion, you have more energy stored. More energy in bond. And that's going to have a greater energy all makes sense. And that's all driven by repulsion. Conversely, if you have less repulsion, you have less energy in bond. And finally, you have less energy released. In both cases, it's when the bond is broken. Cool. Alright, so I'll zoom in on that really quick. If you're watching this at home, right, you can pause it at that point so you can get all the notes down. So let's go ahead and talk about the next question, right? Explain the process through which energy is released, right? So when we look at ATP, we look at ATP, what we have is we have, this is number 5, right? Yeah, so 5. We have ATP, you have 3 phosphates, right? Yeah. Thank you. Cool. Now, when you break ATP, you're breaking this bond, right? This bond between these 2 phosphates. Now, when we think about water and polarity, right? Where is the negative charge? Is it on the oxygen or the hydrogen?
Hydrogen? Oxygen.
Oxygen, that's right. So, when you look at all these oxygens, right? All of them are going to be negative. If you have all of these negative things next to each other, imagine you have all these negative charged magnets next to each other. What is going to happen? What was that? That's right, they're going to repel. So you have this really crowded room with people that don't want to be next to each other. So this is a lot of energy right here. So when this bond finally breaks, you have a lot of repulsion, so you have a lot of energy released. A lot of repulsion between oxygens, a lot of energy released. Cool. All right, so that's what's going on there. Let's keep on trekking on. So the next one is going to be 6, right here. So 6. This energy release is driven by what force? Think about holding hands and leaning back. What is the characteristic of the driving force of these items? What about them drives this force? Visualize the oxygens and the 3 phosphates of ATP. So we talked about this already, right? What is the driving force of energy release? The driving force is repulsion between bonded atoms. Energy release occurs when bonds break. Perfect. Okay, cool. The driving force for these items is the repulsion. Okay? And we already talked about ATP. So moving on to 7. In what process of photosynthesis is light absorbed, is glucose released, and is CO2 absorbed, and is O2 released? So I'll take hands for the 2 processes, right? So for photosynthesis, we have light energy coming in. We have H2O coming in, and then out leaving, we have O2. We use the energy from this light, right? We harness the energy from this light, and what we do is we bring together ADP plus P. Now remember, right, if we're looking up here, ADP, that D, what does that stand for? What does that represent?
Yeah.
Di, and di means? It means 2, that's right. So an adenosine diphosphate, all you have are 2 phosphates, right? So they're right there. Now imagine, you have a giant negative thing right here, and you have to be able to create this. You have to bring in a whole bunch of negative stuff next to each other, right? So basically what you do is we use the light energy to drive the reaction between ADP and phosphate so you can bring them close enough together, even though they're repelling, form ATP. Okay? And in the same vein, or in a similar vein, you have NADP+, right? It has a positive charge. You have to bring in a hydrogen, which has a positive charge. You have to overcome that positive charge repulsion, and you form NADPH. Cool. Now, what is the name of this reaction? And I'll take a hint. Yes?
Light-dependent reaction.
That's right. Light-dependent reaction. Cool. Now, in our next reaction right here, ATP and NADPH are meeting up with this reaction right here. And this is where CO2 comes in, right? So what is the name of this reaction? I'll take another hint.
Light independent reaction.
Nice. Light independent. And this is the entire purpose of photosynthesis. What is coming out? And I'll take a hint. Yes.
Glucose.
Glucose, that's right. Perfect. Cool. Very good. So, when we think about where is light absorbed, it's absorbed in the light-dependent reactions. When we think about where is glucose released, it's released in the light-independent reactions because it's coming out. CO2 absorbed, CO2 is being absorbed in the light-independent reaction. And then finally, where is O2 released? You can look right here and you can see it's in the light-dependent reaction. So this, being able to draw this graphic or see this on your test and write it out is very helpful because if you have a multiple choice question, you can refer back to these diagrams and they'll help you out. So the next question, it can be a little bit tricky. Let's say we did not know the answer to this next one. And the question was, what is the chemical equation of photosynthesis? So we know that this picture represents photosynthesis, right? Synthesis. Cool. So in photosynthesis, this is what you have going on. Now, what are the things coming in? There's 3 items that are coming in. Yeah, go ahead.
So, light,
Light,
CO2,
CO2.
and O2. No, not that.
It's on the picture. Look at the picture.
Where?
On,
What picture?
on the board.
H2O.
Perfect. Now, what are the things that are coming out?
O2 and glucose.
Exactly. So you can see, just like that, makes it super easy, right?
Yeah.
So let's go ahead and go to the next one. What are the products of a light-dependent reaction? And I'll take a hand. What is coming out of the light-dependent reaction? Yes?
Oxygen.
Oxygen, and what else is coming out?
ATP and NADPH.
That's right. So when we look right here, right, we can go ahead and star these. These are the things coming out of the light-dependent reactions, and that's going to be 9, right? For 10, what are the products of the light-independent reaction? What is coming out of the light-independent reaction? Yes?
ADP, positive P,
Yep.
NADP.
And what else?
Glucose.
Perfect. Very good. That was a very good job. That was not an easy one. So we have these 3 items coming out, right? So NADP plus, ADP plus a phosphate, and then also glucose. So I put a little square to indicate what's going on there. Moving on. So we talked about 9, we talked about 10, 11. So this one is a tricky one, right? People had trouble with this one. This is 11. So I'm going to go ahead and give you a little bit of an explanation and then an analogy, okay? So right here I ask you, chlorophyll, mutation in plants destroys chlorophyll B. This prevents the production of blank and leads to the accumulation of blank, blank, and blank. Okay, so if we destroy chlorophyll B is the pigment that allows the plants to absorb light, right? So without that pigment, you cannot absorb light. So if you look right there at 7 at the graphic, 1 second, let me just get through this. You're covering up light, right? You no longer have light. So what happens is you cannot run these light-dependent reactions. They're no longer available, right? You cannot produce new ATP and NADPH, okay? And that's an issue. Now I want you to consider this very short analogy, right? So when you're at home, there's two things that happen for you to eat, right? You have to clean dishes, so dishes cleaned.
Let's write this down.
If you'd like, this is also going to be available on the website. Dishes are cleaned, right? So you have clean dishes. And these are the things that you use for dinner, right? You have to have clean dishes to eat dinner. Now, when you eat dinner, what you get dirty dishes. And then you return them to the dishwasher, right? For dishes to be cleaned, and then you regenerate new clean dishes to continue the cycle. Makes sense, right? Now, in order to clean the dishes, you need soap. And to eat dinner, you need food. Now, I want you to go ahead and look and see the relation between dishes cleaned, light-dependent reactions, light-independent reactions, and then dinner. Cool. All right, so let's say that just in the same way that light is being rejected and no longer included, we go ahead and say that we run out of soap, right? So now we're out of soap. So what happens in this scenario? We have a whole bunch of dishes that are still inside our cabinets that we had, right? So now there's no more soap. So now we use the rest of our clean dishes. We're still eating dinner. What is the thing that's accumulating in the sink? Dirty dishes. Okay. Now when we look at this analogy up here, if we no longer have light and we cannot regenerate ATP and NADPH, the thing that's happening is you're going through this whole process, but you stop right here, right? You're accumulating all of these right here, and you don't have the light that allows you to go and continue the process. So the answer is, when you're looking at the chlorophyll B question, 11, this presents the production, right? You can no longer produce ATP or NADPH, and I guess to a degree, right? O2, can't produce O2 anymore. And then for 11b, just the second part of the problem, this leads to the accumulation of ADP, NADP+, and also H2O. Because now H2O is just like hanging outside your plant. There's nothing that's able to absorb it. So that's the answer to that. That's how it's all tied together, right? So, yeah. And if you don't have this down yet, I'm also going to make scans of it and post it on my website. Question?
What paper or when did we ever talk about chlorophyll B?
That was very shortly in the PowerPoint, but I'm not going to test you on what chlorophyll B is. It was just in the PowerPoint. Cool, so we're at 12. All right, so I'm going to go ahead and put that to the side. Move on to 12. What is the name of the plant organ that absorbs the light for photosynthesis?
Chlorophyll.
That is the name of the pigment. The name of the whole thing that looks like a bean.
Nope. Wait. Yes.
Yeah, go ahead.
This one.
Yeah.
Mitochondria.
Nope.
Dang it. Right plant.
No. No.
Chloroplast?
Yes. There we go.
Ah.
All right, very good. So that right there is going to be 12. The name of that plant organ is a chloroplast.
Which one is that again? 12. No, like, is that the whole bean or is that the things inside the bean?
That's the whole bean.
The whole bean.
The whole organ. Yeah.
Oh,
Okay, cool. The energy of the sun is harnessed in light blank reaction to drive the joining of blank and blank. What is going on there? The light what reaction? That's right. Very good. Dependent. And on top of that, right, the other things that are going to be produced out of those light-dependent reactions include light-dependent. We were just talking about this, right? You were not able to regenerate these. No.
O2.
No.
NADP+.
I was getting to that.
That's right. So NADPH, you can't make that, and you cannot make ATP also. So we kind of had different answers, but we were thinking along the same vein. Okay, cool. All right, 14. So for 14, I'm just going to shortly put these up there, right? Like I said, I'm going to be taking scans of this so you guys can see what the actual answers are. But just to show those people that are working at home right now, let's go ahead and post these, right? So for 14, we're going to go ahead and start right here. Let's see, where are we? Yes, okay. So, right here, so 14, for your light-dependent reactions, you're going to have light.
It's going to be all the tests.
It'll be for labeling. It won't be like this. Yeah, it'll be different. It'll just be like your quizzes. So for right here, the light-dependent reactions include light plus H2O, right? And this is going to help you form O2, ATP, and NADPH. We just talked about that. For light-independent reactions, you have ATP plus NADPH plus CO2 coming together to form glucose, right? And you should be looking at like the diagrams when you look at this, like where is the light-independent reaction? Where do all of these things match up? Do not just go look on here and say like, okay, you know, like this is this, this is this. Match it up with the figure, okay? It's going to be important. So, and that's how you're going to be being tested also. So for this one right here, glucose in glycolysis is broken down into NADH plus pyruvic acid plus 2 ATP. For the Krebs cycle, you have pyruvic acid, and it's being broken down into NADH, FADH2, CO2, and 2 ATP. For the one below, right, oxidative phosphorylation and electron transport chain, you have NADH coming in with FADH2, and then you have the O2, right? And then O2 is coming in, and H2O is coming out, and you produce a whole bunch of ATP. Yeah. Is it still going?
Oh yeah, you have like 2 minutes left though.
Perfect. Okay, thank you. And just let me know. Yeah. Sweet. So we've got that question.
So for every chemical formula, is the red one next to it that one?
Yeah. So for this guy right here, right, for the top one, this is a light-dependent reaction. For this guy right here, this is the light-independent reaction. Right here, it's glycolysis. This right here is the Krebs cycle. Right here is the electron transport chain and oxidative phosphorylation. Good question.
Wait, can you like write them on there so I can see it?
It is written on there. It's in red.
I can't see that.
Yeah. But the video will help. Okay,
Just
cool.
watch the video.
Yeah. Let's go ahead and move on. For the rest of 14, right, we have photosynthesis right here. And photosynthesis, and don't worry about the numbers, right? That's a chemistry thing. The numbers are only on there because that's the way it's properly written. In photosynthesis, the overall reaction includes water, CO2, and light coming in, and out you have glucose and CO2. In cellular respiration, you have oxygen and glucose coming in, and out you have ATP, CO2, and H2O. Now right here, this whole picture, right? This is the slow carbon cycle. And you have a couple things going on. Right here, you have the production of carbonic acid, right? Right here, down here, inside the ocean. Inside the ocean, you have the forming of calcium carbonate. And then, there's a lot of information. You have the production of calcium carbonate. And then, right here, you have the production of limestone, right? Of the ocean. And that helps you form limestone, right? And then right here, limestone, this is more specific. Limestone is going to undergo the heat and pressure of the core. It's going to go into a subduction zone. Production of limestone, and then the production of CO2 under the heat and pressure of the core in the subduction zone. Now, just to let you know, the things that I care more about are going to be carbonic acid production and calcium carbonate production. Okay? So if you're, worried about what to study first, I would study those. Yeah.
Okay, so you said on the test that we're going to be matching. How are we going to match a whole diagram?
You're going to have a word bank, and there's going to be letters on it. And some of those letters are going to be A and B. All right, so we got 2 warnings right here. Okay. So that's what's going on, right? And then it's just going to be long word banks. Some of those are going to be like A, B is going to be the answer choice, A, C. So, yeah.
So it's like when you're doing the quiz or test, are you gonna put that into the diagram? Like
Yeah. Just, if you have questions on the test, just ask. But it's very straightforward. You're familiar with the layout.
alright.
Okay. I need to keep on going. We only have 10 minutes
It's
of class.
actually good.
Is it a joke?
No, it's never a joke. Is that bottom one, is that fermentation or is it W?
That's fermentation. Yeah, yeah. Okay. Hey. Shh. All right. So that's the slow carbon cycle. Now let's say, right, we're running, and we no longer have oxygen inside of our body. What do we do now? We undergo what process?
Fermentation.
That's right, fermentation. And what does fermentation include? It includes pyruvic acid being added with NADH and lactic acid. Pyruvic acid and NADH, they undergo fermentation. And the things you get include lactic acid, NAD+, and specifically 2-ATP. Okay, so it's not a lot, but it's still enough to keep on going. And it's, yeah, that's what fermentation is. Okay, let's keep on going on. We're going to move on to 15.
Yes.
Okay, so 15. While exercising, cramps are a result of the accumulation of lactic acid. And this process called fermentation. Cool. All right, 16. Glucose is used in this process. It's used in,
Photosynthesis.
you produce it in photosynthesis.
Yeah.
It's used
Oh,
in
cellular respiration.
cellular respiration. The specific place where it's broken down is glycolysis. And you have the reaction for glycolysis in the video and in your notes. Let me keep on going. If you have questions, we can answer them at the end of class. Where in the fast carbon cycle is CO2 produced? Right, so when we look at the fast carbon cycle, going on right here, right? And we also have photosynthesis, which is right here. Cool. So we're going to go ahead and look at these, right? And we're going to teach off these 2 diagrams.
That's my car.
Cool. All right. So above we have photosynthesis, and below we have cellular respiration. Cool. So where in the fast carbon cycle is CO2 produced? What number right here in cellular respiration is CO2 produced? Yes.
6.
No.
It is number 2.
No, it's 10. Okay, so CO2 is produced right here, and CO2 comes out of the Krebs cycle right here. Okay, the next question is, NADH and FADH2 are produced in what? They're produced in 2 cycles. The names of those 2 cycles are?
4 and 5.
Oh, I was gonna
That's what they are. So NADH is going to be right here,
Oh.
right? And NADH is going to be right here. FADH2 is going to be right there. Okay. Yeah, so one of them, right? NADH, NADH, FADH2, right? So in the first process, that process is called glycolysis. So, and right here in 6, that process right there is called the Krebs cycle. So in the Krebs cycle and in glycolysis, you're producing NADH and FADH2. Where is ATP produced? You can see right here, ATP is being produced in all of the cycles. So all of the cycles include glycolysis, the Krebs cycle, and the electron transport chain / oxidative phosphorylation. So that's going to be the ETC / oxidative phosphorylation. Cool. All right. The next one asked, where is water produced? Right. So water is going to be produced where? What number? Yes.
Number 9.
Number 9. That's right. So water is coming out right here. Very good. I'm very impressed. 18. ATP production can take on 2 pathways. In the presence of oxygen, this process is, what do we call that process?
Wait.
So I'll go ahead and give you the 2 pathways, right? So glucose is right here. It undergoes glycolysis. And you get NADH, you get pyruvic acid, you also get 2 ATP. Now it's at this critical point your body has to decide, is it going to move on with O2 or without O2? If you move on with O2, you're going to be undergoing the Krebs cycle, which we've talked about and we can look back over. And also the electron transport chain, as well as oxidative phosphorylation. Cool. All right. If you do not have O2, you're going to undergo fermentation. And refer to question 14 on what the chemical equation is. So we're just going to go over the titles. But you have all the information for what is actually going on in there. Now, let's move on to the next one. 19. NADH2 and FADH2 are used to provide power for the, yes?
Oh, what happened to number 18?
We talked about 18 on the quiz papers we wrote on it. 19, NADH2 and FADH2 are used to provide power for the,
Light interaction?
nope,
What did he say?
light independent reaction?
Cells.
No,
Body?
no, yes,
The turbine, TTC.
yes. So the electron transport chain, right? So when we look at this picture right here, and we look at 7, going into 7 we have NADH and FADH2, and we also have more NADH coming in. So right here, those 2 items, right, they're coming in, and they're powering the electron transport chain and oxidative phosphorylation, okay? So right there, you have NADH plus FADH2, and what they're literally doing is they're donating their electrons so that along this chain you have things that can run along and basically pump H plus out, and then, you know, we're not going to go into it, but ATP synthase is going to harness the, yeah, it's okay, don't worry about it. NADH and FADH2 are powering the electron transport chain and oxidative phosphorylation for production of a lot of ATP. Specifically 32 to 34. Cool. All right, let's talk about 20. 20. All right, we're doing really good. I will be pulling questions from the pink packet. So look at your pink packet for the carbon cycles, right? Slow and fast. I would focus on pages 1, 5, and 7, and all of that's posted on the website. Additionally, I'm telling you straight up, right? I'm going to have images like these that are going to be on the test. You need to be able to label them. If you look on the website, I have a document posted that says I'm going to choose one of these 3 images for both the carbon cycling and photosynthesis and cellular respiration. Okay? I'm giving you 3. I told you I'm going to choose 1. Yes?
Is there going to be a word bank?
Yeah, there will be a word bank. Hey, good job, guys.